Hello students, welcome back to OrganiChemVerse. In this video, I'm going to teach you how to convert the given reactant to product by using exactly 4 reagents out of 15 reagents given here. Ultimately, you have to solve for this equation. Now, when the given molecule is undergoing series of reaction, there is only one product. And if you count the number of carbons here, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 carbons. But in the product, there are only 5 carbons. And it's the only organic product. That means what? Somewhere this reaction is undergoing ozonolysis. That means it is splitting into half. That's why we are getting only one product. So it's quite obvious that somewhere I have to use the ozone. And if we use the ozone directly here, that's not the case. That's not the products we are going to get. But what if this double bond shifts here and somewhere it's becoming symmetrical, right? The symmetrical molecule upon ozonolysis will give the product choice. Therefore, we need to shift this double bond. How do we do this? Generally, we do the hydrohalogenation followed by dehydrohalogenation or hydration followed by dehydration. So these are some of the steps it will involve. So let's do it step by step. So for all this kind of reaction, students, remember it's better to always write down the reactions properly. Only then you will get the correct answer. Okay. So this is a reactant. So for this, what I'm going to do first is I'm going to simply add the water because I can do the dehydration and shift the double bond, right? That's the reason. So simple hydration, it will obey Marconi-Cow's rule. What is Marconi-Cow's addition of water? The hydrogen goes to the carbon with more number of hydrogens here, right? And the OH goes with the less number or highly substituted like this. Right? So hydrogen goes here means it will become CH3. What about here? It will become tertiary alcohol. It's a tertiary alcohol. Now, we have to do the dehydration of this. Yes. And also don't forget to write down the numbers of the reagents because later on if you write it will become very confusing. That's why. Okay. So now the Q would be some dehydrating reagent. So what is the best dehydrating reagent we can get here is concentrated sulfuric acid, right? So in presence of concentrated sulfuric acid, heating condition, this will undergo dehydration, but this time we are going to remove hydrogen from this carbon and OH from here. So it will undergo dehydration to form an alkane like this. And also observe here, this is forming a symmetrical. So from here I'm talking, right? This part is symmetrical to this part. Now, simple. We have to split this into two halves. So what is the best reagent for that? Ozonolysis. That is 13, right? So that is R. R is nothing but 13. Ozonolysis. And upon ozonolysis, the first, of course, in the first step, what happens? It forms a ozonoid, right? So after this ozonoid is formed, we have to break that molecule. So how do you do that? For that, we always do the zinc water, that is reductive ozonolysis. So I'm going to write the ozonoid, or you can avoid this step. Okay, so how this will form ozonoid? So like this. You can avoid this step totally, right? So now the last reagent, that is S, is zinc water 4. So that's why it's a reductive ozonolysis, isn't it? So zinc water, and then what you're going to get? A pentanone. In fact, it is a 2-pentanone, right? And 2 molecules of this will be formed. So we have carried out 4 reactions and the reagents are used. Let's solve for P-Q-R-S. 15 plus 11 minus R is 13 and S it's 4, right? So solve for this. What you're going to get here is 9. Therefore, 9 is the right answer. And if you think of any other method, you can comment it in the comment section. Thank you for watching this video.